Hello, in this video we're looking at finding the average rate of change between 2 points. So we've been doing these for our entry tasks and everyone's been pretty good at it. So I'm going to make a point of giving you a challenging example here. I want to remind you of the definition first of what's going on here. So we're going to sketch a quick graph of a curve, and it can be any curve. Here's my curve. Alright, the average rate of change between 2 points, let's say I have a point here and a point here, is a way of approximating the gradient here. So you can see that the gradient at this point is slightly shallower. It gets steeper and it gets steeper and it gets steeper, then it gets shallower again. Well, what the average rate of change does is it says I don't really need an exact gradient. I just want to know roughly what the gradient is. So it says I just want to know what the gradient is between those 2 points. In other words, I want to know how steep that line is. And I promised you a tricky example. So let's say this point is, what will that be? Let's call it -3 on 2, comma -7/8. And let's call this point 5/4 and 2/7. So I'm using fractions on purpose here to make it a bit difficult. We have -3 on 2, -7 on 8, 5 on 4, and 2/7. Well, we need to remember our formula. It's essentially the gradient of a line. You can write it as m if you like. You don't really have to write it any other way. You can call it m. M equals, and you should know this formula from your linear graphs, y2 minus y1 over x2 minus x2 minus x2, x2 minus x1, y2 minus y1 over x2 minus x1. If you like to, you can label these how you like. x2, y2, so this is point number 1, so that's x1, y1. This is point number 2, so that's x2, y2. Let's substitute. y2 is 2/7. y1 is -7 on 8. x2 is 5/4. x1 is -3 on 2. Alright, well, let's get rid of those double negatives. 2/7 plus 7/8 over 5/4 plus 3 on 2, because of course taking away negative is positive. Alright, well, we've got some fractions. Common denominator here is going to be 56 and a common denominator here is going to be 4. So let's rewrite our fractions. I'm going to multiply the top and bottom here by 8. So I'm going to get 16 on 56 plus, and I'm going to multiply the top and bottom here by 7. So we get 49 on 56 over 5 on 4, and I'm going to multiply the top and bottom here by 2. So we get 6 on 4. That equals 16 plus 49 is, what is that? 65 on 56 over 11 on 4. Alright, I chose this example on purpose because I really like this trick. If you've got a fraction divided by a fraction, and I've shown you this before, I like to think of it as folding paper. I think of this as the fold line, and you can imagine that gets overlapped with that, and that gets overlapped with that. So 4 is going to multiply with 65, and 11 is going to multiply with 56. Or in other words, if I have A on B, all over C on D, that equals AD on BC. So let's do that. Well, 65 times 4 is 260. And 11 times 56, well, it's going to be 560 plus 56, which is 616. Is that right? Let's see, 560, yep, plus 56, yep, I'm confident about that. Now we have to cancel down. Well, they're both even numbers, so I can half both of them. 130 over 308. They're both even again. I'm going to half both of them. What's that? Half of 130 is 65 on 154. Alright, what factors could these share? Well, factors of 65 are 1, of course, 5. I can't think of any other factors of 65, can you? Maybe 15, 15, 30, 45, 60. No, 15 doesn't work. Well, there must be one more. 5 times something gives us 65. I think that's 13. Alright, well, does 13 go into 154? No, it doesn't. 13 doesn't go into 154. Let's see, 13 goes into 15 once. Nope. 13 doesn't. So I'm going to claim that that's the answer, and that's the most simplified form. If you can simplify that further, come get a sticker. Claim a star off me. You'll get a star sticker. And if you have been, thank you for watching.